All right, let's talk about something huge. We're going to dive into a technology called GenosDB, and it's trying to solve one of the internet's biggest, most fundamental problems. How do you build stuff online without needing a giant company in the middle of everything?
I mean, think about it for a second. Online, who do you really trust? Every single day, you're handing over your emails, your private messages, your photos, everything really, to these big tech companies. They're the referee, the gatekeeper for pretty much everything we do.
Yeah, most apps we use today need that central server to act as a referee. It's the one source of truth, right? It's what makes sure nobody's cheating the system. But here's the catch, and it's a big one. This creates this massive dependency. What happens if that server goes down? Or the company decides to change the rules on you? The whole thing can just break. It's a single point of control, which also means it's a single point of failure. So what if we could just get rid of that middleman? What if we could build apps that connect us directly, peer-to-peer, with no big company in charge? It sounds amazing, right? A truly serverless internet? But it brings up this massive, critical question. If there's no referee, how on earth do you trust anyone? How do you stop it from just turning into total chaos?
Well, this is where GenosDB comes in with a pretty radical solution. The answer, they say, is to build trust through code. Instead of trusting a company, you trust the code itself, transparent, verifiable code that everyone in the network runs.
This whole idea is called distributed trust, and it's a really fundamental shift in thinking. You're not putting your faith in a CEO or a corporation anymore. Instead, you're trusting a system where the rules are out in the open for everyone to see, where every action can be proven, and where security isn't handled by one company, but by everyone participating, all locked down with cryptography.
Okay, so this powerful idea, it's not magic. It's actually built on 3 key pillars. They're pretty straightforward, but they all work together to make this whole thing possible. Let's break them down. So pillar number 1, cryptographic identity. Basically, everyone gets a unique Ethereum address. Think of it like your digital fingerprint. It proves who you are. Pillar 2, verifiable actions. Every single thing you do gets digitally signed with your private key. This proves what you did and that you were the one who authorized it, no faking it. And finally, number 3, the shared constitution. This is the rule book, the rules of the game. Things like roles and permissions are baked right into the software for everybody. We all play by the same set of rules. Okay, so we've got identity, we've got verifiable actions, and we've got the rules. But who actually enforces those rules? Well, this is the really cool part. Every single person using the app becomes their own guard. See, every device has this thing called a security manager, or SM. The best way to think about it is like a personal bodyguard living on your computer. And its number 1 rule, trust no one. By default, it's skeptical of everything. Before it lets any new information in, it demands cryptographic proof. It checks the digital signature, and it makes sure the action follows the rules in its own copy of that shared constitution.
All right, that all sounds good in theory, right? But how does it actually stop a bad actor? Let's put it to the test. What happens when someone tries to cheat?
Let's look at what we call the Eve scenario. Imagine we have a malicious user, Eve. She's logged in as a guest, but she tries to send a command to give herself the manager role. Now, when that command reaches your device, your personal security manager springs into action. It verifies her signature. Yep, it's really from Eve. But then it checks her permissions in the rulebook. It sees she's just a guest and has absolutely no authority to change her role. So what does it do? It just rejects the action. Boom, attack stopped. And notice no central server was needed at all. And the reason the security manager could do that so easily is because that shared constitution has a clear role hierarchy built in. It's what's known as role-based access control. You've got different levels from guest all the way up to superadmin. Those superadmins are defined right at the very beginning, when the app is created, establishing a secure chain of command from the get-go. So let's just quickly recap the whole model. Step 1, you've got identity plus a signature. That's your Ethereum address and your private key, and it proves who did what. Step 2, you've got the shared constitution. That's the universal rulebook embedded in everyone's security manager. And step 3, distributed security. That's your local security manager trusting no one by default and checking every single operation. Put those 3 things together, and you've got a seriously robust system for trust with no server in sight. Okay, so this is huge. We've figured out how to build trust without a central server. But what's the big deal? What does it actually let us build? This is where things get really exciting. This just blows the doors wide open for a whole new class of apps. Think about it. Real-time collaborative editors like Google Docs, but where you connect directly to your coworkers, no Google server involved. Peer-to-peer video streaming, secure note-sharing apps, even multiplayer games without giant game servers, or decentralized chat and social media, where you control your data, not some massive corporation.
This quote really sums it all up. No central server is needed, only proofs, a shared constitution, and cryptographic consensus. It's a complete shift in how we think about building things online. We're moving away from centralized control and towards a world of distributed agreement. It means we can build a web that's more resilient, way more private, and puts users, us, back in control. We're replacing blind faith in companies with hard, verifiable trust in code.
So that leaves us with one final and I think really exciting question. With this problem of decentralized trust finally solved, what's the first thing you would build? What kind of truly peer-to-peer app does the world need most? The possibilities are pretty much endless.